and Dayal, faculty members, and the Emertex Information Technologies team. It gives me great pleasure to present my internship project titled IoT-based home automation. Before I begin, I would like to express my sincere gratitude to my mentor, Ms. Jayalakshmi and Dayal ma'am, for her constant support and guidance throughout this project. Her classes were superb, and she would clear all our doubts, anything that we have posted on the discussion platform. I am so much grateful for that. Uh, I also thank the Emertex Technologies team uh, for providing such a well-structured learning platform and hands-on training for helping me gain valuable industry experience. Thank you so much. Without any kind of capital investment, that too free. I am so grateful for the whole team for this internship experience. With that, I will be beginning my presentation and just a simulation of my project. Uh, Let me begin with my introduction. My name is Aryasree K. I am a final year electronics and communication engineering student from Government College of Engineering, Kannur. And this project was a part of my internship journey at Emertex in Information Technologies. Um, So this internship was divided into two major phases. The first focusing on the foundations of C and C++ programming, and second about the home automation and the IoT implementation. Through this experience, I learned to integrate hardware, software, and cloud platforms to create a functional home automation system that can be controlled and monitored in real time. Although we are not using an actual hardware, at least we are simulating it, so we will understand how these hardwares are being working have is working. um, oh sorry The main learning goals of this internship were to master the embedded system fundamentals and microcontroller programming, to understand IoT architecture and the cloud integration principles, to develop a functional home automation system and demonstrate real-time remote control, and finally to gain hands-on experience with tools and platforms that are used in the current industry standards. Um, so for phase one, we have that is building the foundation. We started with actually C and C++ programming. So through that, we got a clear an idea about the structure of a programming language, and it was also easier to understand the concept because the whole programming was taught to us in more than a week. So we it was easier for me to grasp as a learner who takes time to learn. And then we went through the electronic fundamentals, like about we studied about different um, the like the uh, the modules that we are using in this, and also about the Pixim Lab simulator and the various Arduino Uno board, the different modules, LDR sensors, this ports and etc., serial communication, etc. Uh, so and also and also actuators, which are the key input and we explored sensors and actuators, which are the key input and output devices in the embedded system. And then and we then in and at last we integrate we studied about the cloud integration and for the home automation project, and we integrated different there were three main modules inside this project. One uh, that is going for the I'm sorry, I'm going for the next piece. Okay, so in the second phase, we like this connection of this different protocols we studied, like the like the IoT fundamentals, like the network protocols and the data flow in IoT systems, um, etc. That is all what we studied, and also the integration, the communication protocols, the Blink platform, how to use a Blink IoT platform, how to call button widgets, gauge widgets inside the platform, inside the Blink IoT platform. And the communication protocol here we are using serial communication and the ethernet connections, since Arduino doesn't have a Wi-Fi module. And also we are integrating, there is since there's all these modules into a single Arduino Uno, Arduino IDE, and where we are writing the code, and after that this code which is loaded as a hex file into the Pixlim Lab Arduino board, and then it is which the Arduino board is connected to various spare parts, various sensors, actuators, devices, sensors, LCD, etc. And also, and how through our phone we are able to control the various spare parts. Now about the project objective. The main objective of this project was to design and implement an intelligent home automation system that demonstrates real world IoT application. The system provides automated control and remote monitoring of household functions such as lighting, climate management, that is mostly temperature sensing, and water tank operations, all through a cloud connected mobile interface. We are The key goals were to automate home functions using sensor feedback, enable smartphone-based control, provide real-time updates, and demonstrate a scalable IoT architecture. Uh, about the system requirements. So the hardware components which we are using in the simulation, that we are using is Arduino Uno LDR sensor, LM35 sensor, which is a temperature sensor. LDR sensor is a light dependent sensor, LED light emitting diodes and relays, simulated tank. So on the hardware side, I used an Arduino Uno as a main microcontroller, an LDR sensor for light detection, and LM35 sensor for temperature monitoring, LEDs for appliance control, and a simulated water tank for level indication. On the software side, I use Pixim Lab for circuit simulation and testing, Arduino IDE for the C programming, and Blink app for IoT connectivity and mobile control. Together, these components form the entire backbone of the home automation uh, system. So this is just the system architecture. The overall architecture of the system can be divided into 4 layers. Sensor layers collects environmental data using sensors like LDR, light dependent resistor, LM35 temperature sensors, and tank level sensors. A control layer, the Arduino processes the sensor data and executes control logic. Communication layer, serial handles data transmission between hardware and the cloud through serial and network protocols. Application layer provides the user interface via the Blink cloud, allowing remote access and control. The layered approach ensures modularity, scalability, and easy debugging. So as I said, there are 3 modules in our project. First one is garden light control. So the first functional block is garden light control system. It uses an LDR sensor to monitor ambient light levels and automatically turn the garden lights on or off. The working principle is simple. When the ambient light drops below a certain threshold, the Arduino activates the lights, and when the light level increases, the lights turn off. Additionally, the set system sends real-time status updates to Blink app, and users can manually override the lights if needed. The smart feature here is that it adapts to seasonal changes in daylight, ensuring energy efficiency throughout the year. Since we are not using a we are not able to sense the sunlight directly, we are using an LDR sensor. So what we are doing is we are changing the intensity of the LDR sensor, that is the resistance of the LDR sensor, and through that resistor the LED brightness is increasing or decreasing, which I will be showing you in the simulation part, which is given at the end of the presentation. Now next module is the temperature control. The second module focuses on the temperature control. The LM35 sensor provides accurate temperature readings with a precision of plus or minus 0.5 degrees Celsius. These readings are continuously monitored and displayed on the Blink dashboard in real time. The system automatically controls the heater and cooler. When the temperature drops below a set point, the heater is activated, and then when it exceeds the threshold, the cooler turns on. Users also receive push notification for extreme temperature conditions, and the system logs historical data of pattern analysis. Although this is possible, we are not integrating it because in our Blink we are using the free version of the Blink IoT app. Therefore, we are not implementing that, but this is possible. This makes the system both smart and user friendly. Now the third module is water tank control system. This module simulates real world water level monitoring using serial communication. But here in the simulation part, we are using a virtual tank, serial virtual tank. We can on and off the inlet and the outlet valve to either to let water into the tank or to let water out of the tank. Now it features automatic filling when the water level drops below a minimum threshold, and automatic motor shutoff when the tank reaches full capacity, effectively preventing overflow. The system also allows remote monitoring through the Blink app, so the user can check the tank levels in real time from anywhere. This module demonstrates how IoT can be used for efficient resource management, not just in homes, but potentially in larger industrial and agricultural setups as well. Through this project, I successfully built a working prototype that automates key home functions and allows remote control and monitoring using IoT. It not only meets the initial objectives, but also lays the groundwork for future scalability, such as integrating more sensors or cloud analytics. This project helped me improve my understanding of embedded systems, IoT communication, and cloud integration. Most importantly, it taught me how to design systems that are practical, efficient, and aligned with real world needs. To conclude this this presentation, this internship project was a rewarding experience that deepened my knowledge of IoT based systems. Um, Next, I will be showing you the simulation part of the project that I've already done.